For today's lecture, we will be focusing on sampling method and central limit theorem. You know that sample is just part of the population. For instance, we are talking about the population of Malaysia. So you have so many people in the population, and sample is just a small part of your population. Okay, you know that it is almost impossible for us to survey or to interview the whole populations of Malaysia. So because of that, you want to save your time, you want to somehow reduce the cost of collecting your survey, so you are using sample. So sample is used to make judgments or inferences about the characteristics of your population. Okay? In this chapter, we will be explaining on the reasons for sampling your population, and we will also be looking at the types of sampling method that we can use when we want to sample our population. You have simple random sampling, systematic sampling, stratified, and cluster. And we will be also explaining about the sampling error, sampling distribution, central limit theorem, as well as normal distribution. Once we finish our chapter, you should be able to explain why do we sample the population, and you should know how to select the sampling method when you want to sample your population, and you should be able to define the sampling error, demonstrate the constructions of your sampling distributions of the sample mean, and you should know on how to explain your central limit theorem, and explain the mean and standard deviations or standard error of the sampling distributions of your sample mean. And lastly, you should be able to apply the central limit theorem if you want to calculate the probabilities. These are some of the reasons why do you have to use sample instead of interviewing the whole population. The first one is that the result of your sample is actually sufficient to estimate the value of your population parameter, and this can actually save your time as well as your money. Second, it's actually too time consuming if you want to contact, if you want to interview, if you want to survey all members of the population. If let's say we are talking about the populations of Malaysia, you know that how large the populations of Malaysia is. So basically it is too time consuming because it is too hard to contact all the population, right? The third one, it may be impossible to check or locate all the members of the population. For instance, you want to study the population of bacteria in the ocean. You know that how large the ocean is, so it is almost impossible for you to select or to somehow test, check these all populations of bacteria in the ocean. So the best way for you is just to use the sample. Next, the cost of studying all items in the population may be prohibitive or very expensive. When you talk about the whole populations of Malaysia, definitely the cost of interviewing everyone is very expensive. And the last one, often testing destroys the sample item and it cannot be returned to the population. It means that, for instance, you want to test how good the quality of the local car is. For instance, we are talking about proton. So you want to know how good the proton is. What is the quality of proton? So how to test the quality of proton? Definitely, you have to drive the proton, right? And you try to drive it like a mad person and get yourself into an accident to check how strong the body of the proton. Okay, so by testing this sample, it actually can destroy the sample. If let's say you want to test the whole populations of proton, what happened to your proton? Definitely you cannot produce any proton. Definitely you cannot actually sell the proton. So sometimes in this case, if let's say you are destroying the population, it is best for you just to test the sample. In general, there are actually 4 types of sampling method. The first one, we call it simple random sampling. So what is this simple random sampling? It means that all members of the population have the same chance of being selected for the sample. If let's say we are talking about the classical example, so you have a box that full of balls. So if let's say this one person want to select one ball and the eyes of this person is closed, means that he covered his eyes. So basically all the balls have the same chance of being picked by this person. Okay, this is what you call simple random sampling. The second one is systematic sampling. So a random starting point will be selected. If let's say you want to apply this systematic, so you will select a starting point randomly, and then every case item means that every 10 items or 11 items will be selected for the sample. Okay, we will discuss about the details in the next slide. And the third one, we call it stratified sampling. It means that the population will be divided into several groups because this group have different characteristics. That's why you will divide them into a few groups. And this group is called as strata. Then a random sample will be selected from each group or from each stratum. The last one, we call it clustered sampling. So it means that the population is divided into primary units, or we can say that we will divide the population into small groups, and then samples are drawn from this small group or primary units. The most widely used methods of sampling is called as simple random sampling. Simple random sampling means that every person in the population has the same chance of being selected. For instance, there are actually 750 baseball players. So you want to form a committee of 10 players to study the issue of concussion. So to make sure that every player has an equal chance of being selected to become a committee, so you ask the players to write down their name on a piece of paper, and then you ask them to place their name in a box, and you mix them up, and then from the box you will just select 10 names, and these names are selected randomly. So you call this simple random sampling method. You can also apply simple random sampling using a tables of random number. Remember, you have 750 baseball players and you want to form a community of 10 players. So how you want to do it using this table of random number? So for your information, random number table is a very big table and you have a lot of numbers there. So what you can do is that the first one, you have to randomly pick a starting number. For instance, in this case, randomly you want to start with this number. What is the number? 03759. So this is your starting point and you select your starting point randomly. Okay, so what is the number of your player? You have 750. Remember, you have 750. And in this number, you have 03759. Okay, so you know that 750 is consists of 3 digits. 1, 2, 3. Okay, so you have to stop at 3 digits as well. So you have 0, 3, 7. So you are selecting a player of number 37 because you are selecting 3 digits. And then you can move to the left or you can move to the right. You can move up and you can move down. It is actually randomly, so it's up to you. So in this case, let's assume that I want to move to my right side. So select 3 digits as well because your total population is 750. You have 3 digits. So you have to select 3 digits, which is 447. So now you are selecting a player with a number of 447. And then you want to move to the right as well. Okay, why didn't you choose this number? Because if you want to select 3 digits, you have 961. The total population is 750. 961 is actually exceeded your total number of population. And then the next one is also exceeded the population number. And the next one is the player number 189. And after this point, you can move up or you can move down. It's all up to you because you can do it randomly. Okay? In the previous example, we have a list of 750 players, and out of 750 players, we will select 10 players randomly. But what happens if you don't have the list of the entire population to begin with? So how can you sample your population randomly? In this case, you can use systematic random sampling. So what is systematic random sampling? Basically, a random starting point is selected. So you will select your starting point randomly, and then every cast member or every 5 members, every 6 members, 10 members of the population will be selected as your sample. So let's look at the example. For instance, these grocery stores want to study the length of time their customers spend in the store. So what will they do? Remember, we have to select the starting point randomly. So the starting point can be the day of the week. For instance, you want to select Monday as the starting point. So every Monday you will select your sample. Or maybe you can select the time as your starting point. For instance, every day you will select your sample, but only at the times of at noon time. For instance, at 12 you will select your sample. And after selecting your starting point randomly, then systematically you can select the customer. It means that, okay, for instance, we are talking about the day. Every Monday we will select our sample. And how do we do it systematically? It means that every 10 customer will become our sample. Or perhaps we are talking about the time. So at 8 a.m. is our sampling time. So perhaps after that we want to make it systematically. So what will we do? Every 5 members of the customer will become our sample. Okay, so this is what we call as systematic random sampling. When we sample our population, we want to make sure that our sample is representative of our population because we don't want to achieve a biased result. However, when we discovered that our population has different characteristics, or in other words, we can say that the population can be divided into a few groups based on different characteristics. So in this case, we have to use stratified random sampling. Let me give you another example. For instance, you want to study the shopping behavior of customers. So you know that different gender will have different shopping behavior. For instance, when you talk about female, perhaps they will love to spend a lot of time doing their window shopping. However, male may love to do something else, or they may not be interested to do window shopping like female, right? So in this case, when you talk about customer, you can divide the customer into different gender because different gender will have different shopping behavior. Another example when you want to use stratified random sampling is that, let's say you want to study the academic performance of university students. So you discovered that when you talk about students, you can divide into two types of students. The first one is part-time and the second one is full-time students. So you know that different status of the students will have different results in their academic performance. Okay, let me give you another example. If let's say you want to use stratified random sampling. For instance, you want to study the factors that affect the well-beings of citizens in Malaysia perhaps. Okay, so you discovered that, well, perhaps the citizen can be divided into two. You have poor citizens and rich citizens, and different types of citizens will have different factors that can affect the well-being, right? So in this case, if let's say your population has different characteristics, you have to use stratified random sampling, or else your result will not be representative of your population. So let's look at the example given by the slide. Okay, in this example, you want to study 50 out of 352 largest US firm. Okay, so when we talk about firm, how can you classify the firm? Well, normally when we talk about firm, you will only think about profit. So firm can be classified into different profit, right? So in this case, you have classified the firm into a few stratum. You have 5 stratum. The first group, the profit is very huge. So what is the profit? 30% and over. The second stratum, the profit is between 20 up to 30%. And you also have another group, the fifth group. Perhaps this is a small group or small firm that has deficit. Okay, and then you know that there are actually 8 firms that belongs to the first group, and you have 35 firms belong to the second group, and so on. In total, you have 352 US firms. Okay, so how you want to sample from these 5 groups or from these 5 stratum? Okay, if you want to sample from these 5 groups, you have to compute the relative frequency. Okay, how to compute the relative frequency? Okay, so the first group, you have to take the number of firm. The number of firm is 8. and you have to divide with the total number of the population, which is 352. So this will give you the value of 0.02. So let's try to compute the second group. You have 35 over 352, and this will give you the value of 0.10. Okay, now you have how many sample? You want to sample 50 US firm. So how to sample from each group? Okay, so number of sample. Okay, how to find it? So you have to take the relative frequency, which is 0.02 multiply with the total number of your sample. So you want to sample 50 firm. So this will give you the value is around 1. So let's try with the second group. So you have, what is the relative frequency? You have 0.10 multiply with 50, and this should give you the value of 5 sample. Okay, you can also try to compute the other example. Okay. The last types of sampling method is called as cluster. Cluster is used to reduce the cost of sampling over a large geographic area. So let's look at the definition given by this slide. A population is divided into cluster, or we can say into a few groups, using naturally occurring geographic or other boundaries. Then clusters are randomly selected, and a sample is collected by randomly selecting from each group. So let me give you another simple example. So when you talk about Malaysia, okay, you want to study the effects of COVID-19 on the well-being of Malaysian. Okay, so in Malaysia, we have so many states, right? So let me write it here. So this is Malaysia. Okay, you have many states here, many states. Okay, but it is impossible for us to interview everyone, every state. So from this state, maybe you will just collect a few states. So you will select your few states randomly. Perhaps you will select Selangor, Melaka, and Negeri Sembilan. So you will select the state randomly. So from each of these states, you will also select your sample randomly. So everything, the state will be selected randomly, and the sample will also be selected randomly. So this is the example for cluster sampling. We use sample to estimate our population. However, it is unlikely that the mean of our sample will be exactly equal to the means of our population. So this is what we call sampling error. So what is sampling error? There is a difference between a sample statistics or your sample mean, we call it X bar, with your population mean or your mu. So in other words, we can say that our X bar is not equal to the mu. So this is what we call sampling error. So let's look at the example here. So we are talking about the number of room rented in June. So in June, you have 30 days. Okay, so the mean number of room rented, your mu here, or we can say our population mean, is equals to 3.13. So in this stage, I assume that all my students should know how to compute the population mean. So how to compute it? Let's look at the observation. The first observation is 0. So summations of all the observation, 0 plus 2 plus 3 until the last observation, which is 3. Summations of all observation divided with 30. So you should get the value of 3.13. Okay, now you are taking 3 random sample with the size of 5. So what does it mean? It means that you're going to have the first X bar or sample mean, and then you're going to have the second X bar and the third X bar, right? Because you are taking 3 random sample with the size of 5. So with the size of 5 means that you have 5 observation. Okay, for instance, you are taking 3, 2, 3, 4, 2. So summations of all these observation divided with 5. So you should get the value of the sample mean. So let's assume that you have computed the first sample mean and you got the value of 3.8. The second sample mean you got the value of 3.4, and the third one you got the value of 1.8. So how can you compute the sampling error? And what is the formula of sampling error? So the formula to compute sampling error is X bar minus mu. As simple as that. So let's try to compute it. So the first X bar, what is the first X bar? 3.8 minus your mu, 3.13. So you should get the value of 0.67. So this is the value of your first sampling error. Second, if you want to compute the second sampling error, so your x bar is 3.4 minus your population mean 3.13. So this should give you the value of 0.27. And you can also compute for the third x bar to get the new sampling error. Okay? Since you have learned about sampling error, how can you determine how accurate your sample mean is? Because we are going to use the sample to estimate our population. But now you know that there is a sampling error. So how confident you are with your estimation? So according to the sampling distributions of the sample mean, for a given sample size, the mean of all possible sample mean selected from your population should equals to the population mean. In other words, we can say that, let's say you have 3 sample mean. So x bar 1 plus x bar 2 plus x bar 3. And then if let's say you want to find the means of your sample mean, so you have to divide with 3. This sample mean should all equals with your population mean. Okay, so we will explain the detail in the next slide. And next, there is less variation in the distributions of the sample mean than in the population distribution. Okay, when we talk about sample, normally we have a small number of observation. For instance, we have 5 number of observation in the sample. So the variation will be very small. For instance, this small. But when we talk about population, definitely you are dealing with a large number of observation. So your population will look like this. So the variation is actually larger. Okay, so definitely your sample estimation is actually accurate. Next, the sampling distributions of the sample mean tend to become bell shape. Okay, we will explain all these 3 information in detail in the following slide. Examples of the sampling distribution. Tata's Industries has 7 production employees. So these 7 employees is the population because this industry only has 7 employees. So the hourly earnings of each employee is given in the table below. So you have 4 questions and these 4 questions will be answered in the next slide. Okay? The first question, what is the population mean or what is the mu? So summations of all your observation, okay, you have 14 plus 14 until all the observation divide with 7, you should get the value of 15.43. So you have to remember your mu is actually equals to 15.43. Second question, what is the sampling distributions of the sample mean for samples of size 2? In other words, you want to find the possible outcome when your sample is actually with 2 observations. So for instance, you want to pair Joe with Sam, Joe with Sue, Joe with Bobs, and so on. So what is the formula for your sampling distribution? The formula is capital N, I think let me write it here, capital N, C, small n. So what is the capital N? Your total population, which is 7, C, and N is your samples of 2. So when you put this in your calculator, you should get the value of 21. So basically, if let's say you want to sample 2 observation, so you're going to have the possible outcome of 21. Okay? Question number 3. What is the means of the sampling distribution? Basically, the mean of each sample has been computed in the previous slide. So in this question, you are asked to compute the means of the sampling distribution. Or in other words, what is the means of your 21 possible outcome? Okay, so in the previous slide, you can see 3 times of the sample mean, which is equals to 14. And you can also see 9 times of your sample mean that is equals to 15. So if let's say you want to compute the means of your sampling distribution, so basically you can use weighted mean. Well, basically you can also use arithmetic, but I think it is easy to compute using weighted mean. So what is the formula? So 3 is the weighted, and you have to multiply with 14 plus the second weighted 9, multiply with 15 plus 6 multiply with 16, and then plus 3 multiply with 17, and then you have to divide with the 21 possible outcome, and this will give you the value of 15.43. Okay, so this is your means of the sampling distribution. Question number 4. What observation can be made about the populations and the sampling distribution? So the first observation is that the mean of the distributions of the sample mean, we have computed it in the previous slide. We got the value of 15.43 is actually equals to our population mean, and we have computed the mu in question number 1. Okay, second observation, the spread or dispersion in the distributions of the sample mean is actually less than the spread in the population value. So when we talk about the population, so if you look at this diagram, you have population distribution and you also have the sample distribution. So if you want to draw a diagram, okay, you can see here you have a bell curve shape here, and this is for your sample. And if let's say you want to draw for your population, you will have this kind of shape. So if you want to see the spreadness or the variance, so for the sample you have this variance, but for the population you're gonna have huge variation, right? So you can see that the variance or the spread in the sample is actually smaller than the spread in the population. The third observation, the shape of the population and sample distribution are different, right? You can see here, basically the shape in the sample look like a normal bell curve shape, while in the population you can see half of the normal distribution shape. So you can see this kind of shape is just represent the half of the bell curve shape. Okay. Central limit theorem says that if samples of a particular size are selected from any population, the sampling distributions of your sample mean is approximately or will look like a normal distribution. So normal distribution is actually your nice bell curve shape, and your estimation will improve with larger sample or larger n. So these are the assumptions of your central limit theorem. The first assumption, if your population follow a normal probability distribution, so your sample will also be normal. Second assumption, if let's say your population distribution is symmetrical, so your sample will have a normal shape when you have at least as small as 10 observation. If let's say your distribution is skewed to the left or to the right, if let's say you want to draw a diagram, so this is skewed to the right and this one is skewed to the left, or you can say that you have thick tail, so it requires your sample to have at least 30 observation or more, so that you can have your sample to look like normal distribution. Okay. According to the central limit theorem, regardless of the shape of our population, if you look at here, this is the first shape of our population, second, third, and fourth, they are all not normal. Regardless of their shape, the shape of our sample will always look like normal. Okay, and based on central limit theorem, it also says that our estimation will improve with larger n. So if you look at here, you have n equals to 6, and the second one you have n equals to 30. Why is the second observation is better than the first observation? Because if you compare the variation, the dispersion, the second one has lesser variation compared to the first one. Okay. In short, we can say that the mean of our sampling mean should equals with the population mean. Next, the standard deviation of the sampling distributions of the sample mean is also called as the standard error of the mean. So when we talk about deviation, it means that we are making an error. So if you want to look at the formula of standard error of the mean or standard deviations of the mean, basically your sigma is divided with the square root of n. So this formula explains to us why there will be less dispersion in the sampling distributions of our sample mean, because when we talk about population, the deviation or the error is only represented by sigma. However, for the mean, the sigma is divided with the square root of n. So it means that our dispersion or our deviation or variation will become smaller. So the conclusion for normal distribution is that if your population follow a normal distribution, so our sample should also be normal, right? If the population is not normal, the sampling distributions of our sample mean will approach a normal shape or normal distribution when our sample size is at least 30 observation. So let's try to compute a normal distribution. So in this case, we will assume that our population standard deviation, our sigma, is known. Okay, so now we can compute our normal distribution using this z formula. So what is the formula? Z equals to x bar, which is your sample mean, minus the mu or population mean over sigma divided with square root of n. Okay, we will look at the example in the next slide. The Quality Assurance Department for Cola Incorporation maintain records regarding the amounts of cola in its jumbo bottle. So the actual amounts of cola in each bottle varies a small amount from one bottle to another. Records indicates, okay, when you look at these words, records, so it refers to your population. So records indicates the amounts of cola follow the normal distribution. The mean amounts of cola. So the mean here refers to your record, so this is your mu. Okay, it is better to write down all the information. So your mu equals to 31.2, and the standard deviation also refer to the record, which is to the population. So this is your sigma, which is 0.4. Okay, at 8 a.m. today, the quality technician randomly selected 16 bottle. So this 16 is actually your n, right? Okay, the mean amount was 31.38. So what is this, the second mean? So it refers to the random number, means that you randomly selected the sample, isn't it? So it is referring to your sample mean. So this is your x bar, which is 31.38. So the question is this an unlikely result? Because your population mean is 31.2. but your sample mean is 31.38. The question can also ask you, is it likely the process is putting too much soda in the bottle? The question can also ask you, is the sampling error of 0.18 unusual? Or it can also ask you, what is the probability of x is equals or bigger than 31.38? Okay, now how can you answer this question? So what is the formula to compute the z? So you have x bar, so where is my marker? Oh, it's here. You have x bar, sample mean minus population mean over sigma divide with the square root of n. So you have listing down all the information. Just plug in all this information into the formula, so you should get the value of your z equals to 1.80. Okay, is this the final result? To find the probability? No, you know that you have to convert it into the z table, right? So when you look at the z table and the value of 1.8, it will give you the answer of 0.4641. Okay, but this is not our concern, because our concern is that the question asks you, what is the probability of x is equals or bigger than 31.38? So here is your 31.38. Your mean, your population mean is 31.20. So you are interested to find this part, whether you can have more than this value, 31.38. So how to find this small area? So you know that half of this diagram will give you 0.5. So 0.5 minus the value that you have computed or you have found out from the z table, which is 0.4641. So this will give you the value of 0.0359, or we can just convert it into percentage like 4%. Okay, so how can we answer this question? We can conclude that it is unlikely result, or there is less than 4% chance to have this kind of problem. Okay.